Hello dear students, good evening to each and everyone, and all of you welcome back on Wallah English channel. In this channel we are studying signals and system in comprehensive manner. Already total we completed 24 lectures and this is lecture number 25. Topic name is classification of signals. This is part 4. First of all tell me, am I audible properly? Audio and video both are clear to you people? Audible or not? All of you tell me in the comment box. Audible guys? In last class we have started periodic and aperiodic signal. Periodic and aperiodic signal. In this class today we will finish first periodic aperiodic signals, then we will see bounded unbounded signals, analog and digital signals, and random and deterministic signals. Okay, so let us continue. We are studying periodic and aperiodic signal, correct? Now see again, yesterday we have seen this question also. Here fundamental time period from -3 plus 3. This is known as the first cycle, positive half cycle, negative half cycle, and here fundamental time period is 6. The fundamental frequency is inverse of fundamental time period, is 1/6. Unit is cycles per second, or well known unit is hertz, and here unit is second. Here what is the fundamental time period? You can say -3 pi to pi. This all are what? Non-sinusoidal periodic signal. This is negative half cycle, this is the positive half cycle. So here -3 pi to pi, fundamental time period is 4 pi. If you want to calculate the fundamental frequency f, it is the inverse of fundamental time period. Okay, -3 pi to pi. Next, question number 3. Now see here, this is sawtooth waveform guys, with positive amplitude only. Here there is no negative half cycle. Okay, so what is the fundamental time period of this signal? What is the fundamental time period? So here you can say this is the one cycle, this is second cycle, this is third cycle, and fourth cycle, and so on. Correct? So here non-sinusoidal periodic signal, fundamental time period 0 to 2, the fundamental time period is 2 seconds. The fundamental frequency is 1/2 hertz. Hertz, or you can say cycles per second. Okay, and you can see here this signal is non-zero DC value, non-zero mean value or average value. Now next, question number 4. Now find the fundamental time period of this signal. It is also very much important. Fundamental time period of this signal. So you can see here it is from -2, one cycle, -2 to +2. Correct? -2 to +2. This is the fundamental time period. -2 to +2. Clear? So the fundamental time period T is equal to 4. The fundamental frequency is by 4. Unit is hertz. Here unit is second. Clear? Fine. Okay, next here. Now this is also periodic signal. See, the first cycle we can say, this is the second cycle. Correct? Duration should be same. The -4 to -2, -2 to 0. Correct? Then 0 to 2, 2 to 4. This is also periodic signal, and the fundamental time period from -1 to 1. The positive half cycle, this is the negative half cycle. So the fundamental time period is 2 seconds. The fundamental frequency is 1 by 2 hertz or cycles per second. If you want to find the angular frequency, then it should be 2 pi by t or 2 pi f. Angular frequency is pi f. So 2 pi into 1 by 2 equal to pi, and unit should be is what? Radian per second. Okay. Now next is question number 6. See, tell me whether this is periodic or aperiodic. If it is periodic, what is the fundamental time period? What is the fundamental time period? As you can see here, this is also periodic, guys. This is also periodic signal. You can say this is the positive half cycle and this is the negative half cycle. Again here, this is the positive half cycle and this is negative half cycle. Correct? So -5 and -1, between -5 -1, same between -1 and 3, guys, and so on. This is also periodic signal. The fundamental time period from -3 to 1, you can see this is the positive half cycle and this is the negative half cycle. What is the fundamental time period? The fundamental time period T is equal to -3 and 1, which is what, 4 seconds. The fundamental frequency is 1 by 4 hertz, you can say here. So these all are the what? Non-sinusoidal periodic signal. Okay, non-sinusoidal periodic signal. Now this one already we have seen -3 to square wave, we can say -3 to 3. Fundamental time period is second. This is positive half cycle, this is negative. Now sinusoidal, all the continuous time sinusoidal signals are always periodic. Correct? All the continuous time sinusoidal signals are always periodic. Fine. So this is A sin omega t. If it is A sin omega t, x of t is equal to A sin omega t, A sin omega t, then here omega is nothing but your fundamental frequency by f, nothing but pi by capital T. Okay, capital T, and this omega is known as the angular frequency, as I told you guys, radian per second. F is your frequency in hertz. Capital T is the fundamental time period. Fundamental already we discussed this sinusoidal function in detail in the some standard signals topic. Okay, fundamental time period. Also periodic signal. All the periodic signals are everlasting, means infinite duration, everlasting. Okay. So here peak amplitude is A, and here you are writing T, guys. So T, that means you have to write in the fundamental time period format. This is T by 2, and this should be what? Minus T by the positive cycle, this is the negative cycle, this is capital T, and this is minus. Okay, so here this is the one cycle, or you can say this is one cycle, second cycle, third cycle, and so on. This should be 2T. Okay, So this is known as what? Positive half cycle. This is the negative half cycle. Amplitude is minus A. Here it should be minus A, right? Clear? Is it clear? Fine. Now let us solve some question. Let us find fundamental time period of sinusoidal function. Sine means sinusoidal function means it can be sine or it can be cos also. What is the difference between sine and cos? Only just difference of phase shift of 90 degree. Okay. This is T1. X of t equal to A cos 200t. X of t A cos 200t. So compare it with the standard format. Cos omega t. Cos omega t. From here, omega is equal to 200. This is the angular frequency, 200 radian per second. It is nothing but pi by capital T. So here, the fundamental time period is equal to fundamental time period. It is pi by 100, pi by 100 second. And if you want to calculate the frequency, fundamental frequency f, it is the inverse of capital T, that is 100 upon 100 by pi hertz. Okay. So each and every continuous time sinusoidal signals are always periodic. Okay. Now next question. See, so number 10. So number 10. Now see the question number 10. Find the fundamental frequency of this sinusoidal function. So x of t equal to 4 sine 100 pi t. So here omega is equal to, if you compare with standard format, so omega is nothing but 100 pi radian per second. It is nothing but 2 pi by capital T is 100 pi. So T is equal to 2 by 100 by 100, we can say nothing but 20 milliseconds. Okay, and the fundamental frequency f is inverse of fundamental time period. 100 by 2 is nothing but 3 hertz. 3 hertz, or we can say 50 cycles per second. Now 50 cycles per second means in one cycle you will get total 50 cycles. Okay, this is one cycle. Similarly, this is second cycle, then third cycle. So like this you will get the 50 cycles in 1 second. This is the meaning of frequency f. 50 hertz or 50 cycles per second. Fine. So guys, each and every continuous time sinusoidal signal is always periodic. Now see, this fundamental time period do not depends on what? Amplitude. Now here next. So additional phase shift, guys. Additional phase shift doesn't alter periodicity of the given signal, because due to this phase shift, signal will shift either right side by certain units or left side by certain units. But there is no change in the width, or we can say fundamental time period. So conclusion is additional phase shift does not alter the fundamental time period of the given signal. So again here, even there is a negative amplitude, then also no problem, and just amplitude reversal. So here omega, simply have to focus on omega. So this here omega equal to again 100 pi radian per second. So capital T, same as previous one. Here also omega 100 pi. Here also omega 100 pi. So it is again 20 milliseconds. The fundamental frequency is again 3 cycles per second or 50 hertz. Okay, very good. Now next, find the fundamental time period of a signal x of t equal to 3 cos square 0.5 pi t. What is the fundamental time period? As you can see here, x of t is equal to cos square theta is equal to 1 plus cos 2 theta divided by 2. So it will be 3 by 2 plus 3 by 2 cos 2 theta cos pi t, cos pi t, correct? Now see, this is DC and this is AC. So if you add DC into the periodic signal, then also there is no change in the periodicity of the periodic signal. Okay. So additional DC cannot change the fundamental time period of the given signal. Here omega is equal to pi. Omega is nothing but pi by capital T is equal to pi. So T is equal to seconds and fundamental frequency is 1 by 2 hertz, or we can say cycles per second. Fine. Now here exponential complex sinusoidal function, again simply you have to compare it with what? Complex sinusoidal e power j omega t, e to the power j omega t. If you compare with e power j omega t, then this will be your omega. Omega will be 5 by 7 e power j theta, where theta is equal to this one, e power j omega t plus 5 phase angle, additional phase angle is 30 degree. So it is 5 by capital T, 5 by capital T equal to 5 by 7. So T is equal to 14 pi by 5 second. Okay, and F is equal to 5 by 14 pi hertz. Now we want to calculate, or we want to cross verify. We want to cross verify whether this our answer is right or wrong. We got answer T equal to 14 pi by 5. We want to check whether this answer is right or wrong. How to check? Already we know that if it is a periodic, x of t plus capital T should be x of t. So let us find x of t. Here we got capital T is 14 pi by 5. So here in this case 10 e to the power j 5 by 7 t become 5 by 7 t become t plus, here t become t plus 14 pi by 5 plus 30 degree. Okay. So x of t plus capital T is equal to, from here 10 e to the power 10 e to the power j is 5 by 7 t plus 5 get cancelled out, it is 5 plus this is 30 degree. So x of t plus capital T, so t plus capital T is 10 e to the power j, to the power j 5 by 7 t plus 30 degree into the power j 5. Now what is the e to the power j 2 pi? It is nothing but cos 2 pi plus j sin 2 pi. This is cos pi plus j sin 2 pi. Now cos 2 pi is 1 and sin 2 pi is 0. So answer is 1. So x of t plus capital T is equal to 10 e to the power j 5 by 7 t plus 30 degree. Okay, 30 degree, which is same as x of t. So we got x of t plus capital T is equal to x of t. So we can say x of t is the fundamental time period, and the fundamental time period capital T is equal to 14 pi by 5. In this way we can cross verify also our answer. Here, each and every one, tell me in the comment box, is this clear or not? Fine. Now next question. See here. Tell me whether this is periodic or aperiodic. If it is periodic, then tell me the fundamental time period. Sine root 3t. Periodic or aperiodic? Periodic. If it is periodic, then tell me the fundamental time period. If it is periodic, tell me the fundamental time period. Omega is equal to 3. Omega is equal to root 3. Here, pi by capital T is equal to root capital T is equal to pi by our fundamental time period. Now again we want to check whether this fundamental time period is right or wrong. So x of t plus capital T, that is x of t plus pi by equal to here tan sine to 3, instead of t you are replacing t with t plus pi by root 3. Here x of t plus capital T tan sine t plus root 3 can cancel out, is 2 pi. Now sine 2 pi plus theta, sine 2 pi plus theta, that is nothing but sine theta, which is equal to tan sine to 3 t, correct, and which is same as x of t. So again we got x of t plus capital T equal to x of t. So we can say yes, this is also periodic signal and the fundamental time period capital T is equal to pi by root 3 seconds. Done? Fine? Okay. Very good. Next question. Now find the fundamental time period of the given signal. If it is periodic, tell me this is periodic or aperiodic signal? Periodic or aperiodic? This is periodic or aperiodic? Is periodic or aperiodic? Tell me in the comment box. Of course, this is what aperiodic signal. You can check x of t plus capital T 1 plus 2 t plus capital T plus t plus capital T whole square. Of course you can see here this is not equal to x of t in any case. That's why one signal x of t is aperiodic. aperiodic signal, correct? Given signal x of t is aperiodic signal. Here to each and everyone, fine? Aperiodic. Now next question. Now next is what? So till now we have seen the individual periodic signal. But suppose if any general signal x of t is a combination of more than one periodic signal, then the resultant signal will be periodic or not? Be periodic always or not? Correct? So if x of t is a combination of more than one periodic signal, then the resultant signal will be always periodic, or it will be periodic under certain condition that we have to check. So here for this I am talking about the continuous time signal. Procedure to check periodicity of signal x of t if it is combination of more than one periodic signal. Say for example, x of t is equal to x1 of t plus x2 of t, x3 of t, x4 of t and so on. This is periodic signal with fundamental time pair capital T1. This is periodic signal, fundamental time pair capital T2, and the fundamental frequency here. This is periodic, the fundamental time period, fundamental frequency omega 1 and fundamental time period T1. This is also periodic, the fundamental frequency omega 2, fundamental time period T2. This is also periodic, fundamental time period, fundamental frequency omega 3, fundamental time period T3. This is also periodic, fundamental frequency omega 4, the fundamental time period T4. So all the signals individually periodic. Individual period combination means it can be plus, it can be minus also, guys. Combination means plus or minus. Okay. So the resultant signal x of t will be periodic or not. How to check? So step number 1. What is the step number 1? Find the fundamental time period of each signal. Fundamental time period of each signal, that is T1, T2, T3, T4 and so on. Okay. The next step is find the ratios T2 by T1, T3 by T1, T4 by T1. That means you have to find the ratio of any two quantity, any two fundamental time period, like T2 by T1, T3 by T1, T4 by T1, or you can say T1 by T2, T1 by T3, T1 by T4 and so on, guys. Even you can find the ratio of frequency also, like omega 2 by omega 1, omega 3 by omega 1, omega 4 by omega 1, correct? You have to find all the ratios. This is the step number 2. And if all of the above ratios are rational number, then x of t is said to be periodic signal, otherwise it is said to be aperiodic signal. For the x of t signal to be periodic, all these ratios should be rational number. If at least one ratio is irrational number, then the given signal x of t is said to be aperiodic signal. And if the x of t is periodic signal, if all the ratios are rational number, x of t is periodic signal, then the fundamental frequency and fundamental time period is given by LCM of individual fundamental time period, and the fundamental frequency is given by SCF, not HCF, highest common factor, or GCF, greatest common factor. SCF of individual frequencies. This is very much important. Fundamental frequency omega 0, fundamental time period T0. So the fundamental frequency omega 0 is given by SCF of individual fundamental frequencies. This is very much important, guys. Okay. Now let us solve some question based on this, because this concept we will use in the Fourier series also, because Fourier series is defined only for the periodic signal. Okay. So before finding the Fourier series, first of all we need to check whether the given signal is periodic or not. So let us start with the very first question given. Find the fundamental time period of signal x of t if it is periodic. First of all we need to check the periodicity of the given signal. See, individual continuous time sinusoidal signal is always periodic, but combination may or may not be periodic in the continuous time. So this is periodic, this is periodic. Here fundamental frequency omega 1 is 100 pi, is pi by T1 equal to 100 pi. From here T1 is equal to pi get cancel out, T1 is equal to 1 by 100 seconds. Here omega 2 is equal to 150 pi, 150 pi, pi by capital T is equal to 150 pi. So T2 is equal to 1 upon 75 seconds. Okay. Now you have to find the ratios T2 by T1 or T1 by T2 ratio. So T2 by T1, so T2 is 1 by 75 and this is 1 by 100. Okay, 1 upon 100. So it is nothing but 100 by 100 upon 75. So I think this is 4 by 3. 4 by 3 is equal to 1.333333 and so on. So tell me, this is the rational number or irrational number? 1.333333. So we know that ratio of any two integers always rational number. So here this is the rational number and the given signal is rational number and this indicates x of t is periodic signal. Combination is periodic. Periodic signal. If it is periodic, then the fundamental time period or fundamental frequency omega 0, fundamental frequency omega 0 is SCF of individual frequency omega 1 and here omega 2, the two frequencies. So omega 0 is equal to SCF highest common factor or GCF greatest common factor 200 pi plus 200 pi and 150 pi. 200 pi and 150 pi. So what is the highest common factor here? So highest common factor is nothing but I think 50 pi. Correct? Highest common factor is pi and HCF of 200 and 150 is 50 pi. So the fundamental frequency is 50 pi radian per second. Omega 0 is okay. So this is omega 0 and what is the fundamental time period? So from here also you can find pi by T0 which is equal to T pi. Fundamental time period is T0 is equal to 1 by 25 seconds. Now using LCM also we can find the fundamental time period. Fundamental time period is equal to LCM of individual fundamental time period T1 and T2. T0 equal to LCM of first is 1 by 100 and second is 1 by 75. So how to find the LCM of P1 by Q1 plus P2, P1 by Q1 and P2 by Q2? The method is LCM of numerator, already you know that guys, LCM of numerator and HCF of denominator. It is the form of P1 by Q1 and P2 by fraction format, P2 by Q2. LCM is 1 and HCF is 25. Again we got the correct answer. Again we got the same answer 1 by 25 seconds. Now again we want to check whether we got the right answer or wrong answer. So there is a method I already told you. First of all, x of t equal to 2 sin 200 pi t sin 200 pi t plus t cos 150 pi t, t cos 150 pi t, t cos 150 pi t. Now replace t with capital T plus capital T. Capital T is nothing but 1 by 25. 1 by. So right hand side also everywhere you have to replace T by T plus 1 by 25. plus t cos 150 pi t plus 1 by 25, correct, 1 upon 25, x of plus 1 upon equal to sin 200 it plus this 8 pi, correct, plus t cos 150 pi plus 6 pi, yes or no. Now see here, sin 8 pi plus theta, that is first quadrant, 8 pi plus theta first quadrant, so sin theta, and this is cos 6 pi plus theta, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and again 6 pi. So 6 pi plus theta, again cos 6 pi plus theta cos theta, here x of t plus 1 upon 20 equal to 2 sin theta, that is 200 pi t plus t cos 150 pi t. Now which is same as x of t. So yes, we can say x of t is a periodic signal having a fundamental time period, capital T is equal to 1 by 25, and our answer 1 by 25 is correct. Fine. Is this clear? Tell me in the comment box. The next question. Okay, next question. Find the fundamental time period of the given signal x of t equal to 2 sin 70 into cos 5t. How to find the fundamental time period? 2 sin 70 into cos 5t. So 2 SC formula you have to use. Sin a plus b 70 plus 5t, that is 12t, plus sin a minus b 70 minus 5t sin. Now I told you guys individual sinusoidal functions are always periodic, but combination may or may not be periodic. We have to check. Okay, this is omega 1 equal to 12. Here omega 2 equal to 2. Fine. So ratio omega 1 by omega 2. You can take ratio T1 by T2, T2 by T1, or omega 1 by omega 2, omega 2 by omega 1 also. So 12 by 2, so which is 6, is also rational number. Okay, rational number indicates given signal is periodic. X of t is periodic signal. X of t is periodic signal, and it is periodic, then the fundamental frequency omega 0 given by SCF of individual signal fundamental frequency 12. What is SCF? 2 guys. Omega 0 is nothing but 5 by T0. 5 by T0 equal to 2. T0 equal to T0 is equal to what? 2 get cancel out. It is 1 by pi second. This is what? Fundamental time period. 1 by pi seconds. Clear? Nikhil, tell me, is this clear or not? By pi second is the correct answer. Very good. Let us take one more question. So here, individual sinusoidal functions are always periodic. Combination may or may not be periodic. Here, fundamental frequency omega 1 is equal to pi by 2. Here, pi by T1 equal to pi by 2. From here, T1 is equal to T1 pi get cancelled out, T1 is equal to 4 seconds. Here, fundamental frequency 5 pi by equal to pi T2 1 by 5 by here 2 pi by 5. Now find the ratio T1 by T2 or T2 by T1 ratio. Suppose I am writing T2 by T1. T2 is pi by 5 and divided by T1. 2 pi by 5 divided by T1. So this is pi by 10. Pi by 10. Now tell me, pi by 10 is a rational number or irrational number? So this pi is a non-integer and this is integer. So ratio of non-integer and integer always irrational number. So here this ratio is irrational number and this irrational number, that's why we can say x of t is aperiodic signal. So I told you guys, in the continuous time, all the continuous time signals individually periodic, but combination may or may not be periodic. As you can see here, individual sinusoidal function in continuous time, this is all about continuous time. Individual periodic, but combination, as you can see here, combination here we got aperiodic signal. So not always periodic. Okay, this is very much important conclusion that you have to remember. Fine. Now let us try one more question. Try this question. Now I am expecting answer from each and everyone. All of you have to try this question. Try yourself question. You have only 2 minutes to solve this question. Tell me your answer in the comment box. Tell me your answer in the comment box. Whether this is periodic or aperiodic. If it is periodic, then tell me the fundamental time period. What is the fundamental time period? Here frequency omega 1 is 5 pi, omega 2 equal to pi by 0.3. Can you write like this? 10 pi by 3. Yes, we can write like this, 10 pi by 3. And here omega will be 5 by 5 by 4. Now find the ratio like omega 2 by omega 1, omega 3 by omega 1. Okay, or omega 1 by omega 2, omega 1 by omega 3. Always you will get the rational number. You can check. See, if you want to check, then first omega 2 by omega 1. Omega 2 by omega 1, 10 pi by 3 divided by 1 by 5 pi. It is 2 by 3. 2 by 3 is always a rational number. 2 by 3 is always a rational number. Similarly, omega 3 by omega 1. Omega 3 by omega 1. Omega 3 is pi by 5. Pi by 5. Omega 1 is 1 upon 5 pi. 1 by 5 pi. So it is equal to 3 by 25. 3 by 25. So again you can see 3 by 25 also rational number. Correct? 3 by 25 also rational number. Both the ratios are rational number. Then x of t is said to be periodic. Yes. X of t said to be periodic signal. X of t is periodic signal. Correct? Said to be periodic signal. What is the fundamental frequency? Fundamental frequency is given by SCF, highest common factor of omega 1, omega 2, omega 3. Omega 2, omega 3. Omega 1 is omega 1, that is 5 pi by 1. We can write like this, 5 pi divided by 1. Omega 2, 10 pi by 3. Omega 3 is 3 pi by 5. So I told you guys, it is a form of P1 by Q1, P2 by Q2, P3 by Q3. Then how to find its HCF? HCF of numerator divided by LCM of denominator. HCF of numerator 5 pi plus 10 pi, sorry, 5 pi 10 pi, comma, not plus, divided by LCM of 1, 3, 5, 1, 3 and 5. Omega 0 equal to omega 0. What is SCF? Of course, SCF will be pi. What is LCM? LCM of 1, 3 and 5 is nothing but 15. So this is the fundamental frequency. Now if you want to calculate the fundamental time period, omega 0 nothing but 2 pi by capital T is equal to pi by 15. Here pi get cancel out. Fundamental time period capital T 30 seconds. Okay, so 30 seconds is the correct answer. It is periodic and the fundamental time period is 30 seconds, and you can cross verify also. Okay, cross verify also. T plus capital T, you will get x of t only. So this is a periodic signal. Okay, very good. Now next question. Yes, T2 by T1 also you can do. T2 by T1, T3 by T1, or T1 by T2, T1 by T3. You can find ratio of any two numbers. Correct? Any two fundamental time period. Now this is very much important. Find the fundamental time period of the signal x of t is equal to E1 cos, E1 part of, see this meaning is what? E1 part of cos 5t into U of t. Now see, tell me, here I am giving one question. Suppose x of t is equal to cos 5t into U of t. Tell me whether this is periodic or aperiodic. Periodic or aperiodic. This periodic or aperiodic. Now U of t is multiplied here, guys. So if you multiply with U of t, then it will be right sided only. A cos function for right sided only. that means it is periodic only for right sided. So you cannot say it is periodic signal. Causal periodic you can say, yes. Cos phi t, only cos phi t is periodic, but if you multiply with u of t, then it will be cos function only for the right side, and for left side the multiplied u of t, that's why 0. So you cannot say this is the periodic signal. It is periodic only for the t greater than 0, and for t less than 0 it is 0. So that's why overall it is aperiodic signal, because all the periodic signals are everlasting signal. It should be periodic from t equal to minus infinite to plus infinite. So this is known as aperiodic signal. You can say it is a causal periodic, as it is periodic for t greater than 0. It is known as what? Causal periodic signal. First priority is aperiodic signal, second priority is causal aperiodic signal. Correct? Now next question is, even part of cos phi t u of t is periodic or aperiodic? Even part, periodic or aperiodic? Tell me. Even part is periodic or aperiodic? Even part of cos phi t u of t is periodic or aperiodic? Tell me. How to find the even part? If you want to find even part of this, just consider phi of t. Even part is given by phi of t plus phi of minus t divided by 2 cos phi t of t plus phi of minus t cos minus phi t of minus t of minus t whole divided by phi of t plus phi of minus t divided by 2. Now cos is a even function. Cos phi t of t plus cos is a even function. Cos minus cos phi t of minus t whole divided by 2. X of t is equal to cos phi t divided by 2 common. So it is q of t plus q of minus t. Correct? What is u of t plus u of minus t? Already we have seen the previous topic. U of t plus u of minus t is always 1. It is 1 for all t. It is 1 for all t, guys. That's why x of t is cos phi t divided by 2 and equal to 1 is equal to cos phi t divided by 2. That's why now you can say this is simple cost function. This is simple cost function having a peak amplitude 1 by 2. So it is periodic only. Periodic signal. Is periodic signal, and as this is periodic, what is the fundamental frequency? Fundamental frequency omega is equal to 5, the fundamental time period, 5 by capital T 5. Fundamental time period capital T 5 by 5 second, 5 by 5 second. Correct? What periodic signal? Even part of cos phi t u of t. See, cos phi t into u of t individually it is aperiodic, but its even part is periodic. The similar way, odd part of cos phi t u of t. Now check once, this one is periodic or aperiodic. In the same way, tell me this periodic or aperiodic. whether this is periodic or aperiodic. Tell me in the comment box, all of you. Odd part of cos phi d of, expecting answer from each and every student in box. Whether this is periodic or aperiodic. Aperiodic signal, okay. How to find its odd part? So this is y of t, and odd part is given by y of t minus y of minus t divided by 2. Y of t plus phi of t minus y of minus t minus 5t of minus t whole divided by, okay, whole divided by 2. Here x of t cos 5t of t. Cos is a even function, minus cos 5t of minus t divided by 2. Now again cos 5t common, cos 5t by 2 is 2 of t minus 2 of minus t. So this is nothing but the signum function. Already we have seen signum of t. Cos 5t by 2 and signum. So signum function is nothing but 1 for t greater than 0, and it is minus 1 for t less than 0. So for t greater than 0, you have to multiply cos function with amplitude plus 1, and for t less than 0, you have to multiply this cos function with minus 1. That means amplitude reversal for t less than 0 and same amplitude for t greater than 0. So if we draw this signal, cos function signum function value is 1 for t greater than 0. So for for positive value of time t, cos 5t by 2 multiplied with 1. So same as cos function, multiply with 1. Multiplied with 1, and for less than 0, for t less than 0, cos 5t by 2 is multiplied with minus 1, guys, correct, minus 1. So minus 1 means 3. This is the cos function, complete cos function, correct, cos function. And for t less than 0, this amplitude should be multiplied with minus 1, that is amplitude reversal. Amplitude reversal means it is like this. Correct, amplitude reversal. Now tell me, now check whether this is periodic or aperiodic. Check this periodic or aperiodic. Check the pattern at origin. At origin, it breaks the periodicity. Here you can see it breaks the periodicity at origin. So that's why this is aperiodic signal. You can check at origin, indicates it's aperiodic signal. Correct. This is the aperiodic signal. Got it? Odd part of cos phi d is aperiodic signal. The similar way, check this sine function. Given one part of sine, periodic or aperiodic? Tell me in comment box. Periodic or aperiodic? P1 part sine 5t plus sine minus 5t minus t whole divided by 2. Sine is the odd function, that's why minus sign will come outside. Sine 5t of t minus sine 5t of odd function, that's why minus sign outside here, divided by 2. Again sine 5t by 2 is common. Sine 5t by 2 is common. Bracket 2 of t minus 2 of minus t. This is nothing but your again signum function. Signum of t. Okay. So x of t equal to sine 5t by 2 signum function. Signum of t. Again, see, sine 5t by t by 2 is a periodic signal. But if you multiply with signum function, then definitely signum function will change the periodicity of the given signal. Yes or no? Signum, if you multiply periodic signal with the signum function, then it will change the periodicity of the given signal. Again, here also is what? Aperiodic signal. No, it will be not remains no more periodic signal. It will be aperiodic, or we can say non-periodic signal. Aperiodic or non-periodic. Correct? Aperiodic signal. Very good. This is aperiodic signal. The similar way, tell me. Find the fundamental time period of signal x of t equal to odd part of cos 5t, not cos 5t, sin 5t, because already we have cos 5t, sin 5t, odd part of sin 5t u of t. Periodic. Okay, very good. Yes, answer is correct. So x of t equal to odd part sin 5t u of t minus sin minus 5t minus u of minus t whole divided by 2, whole divided by 2. Sin 5t of t minus plus sin odd function, that's why minus sign come outside, minus plus minus t whole divided by x of t is equal to again sin 5t by common is u of t plus u of minus t, u of t plus u of minus t. Now this is 1 for all t, 1 for all t, it is 1 for all t. That's why this sin 5t by 2 1. So tell me, sin 5t by 2, again of course it is periodic signal. this periodic signal. Here, yes, u of t plus u of minus t is 1. That's why the given signal is x of t is p. Is clear? Now we will see the periodicity for discrete time signal in the next class, guys. Okay. Same thing we will see. We will understand for the discrete time signal also. Okay. So all of you, thank you so much for watching me. All of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion of this as in the comment box, and next part we will continue in subsequent module. Thank you guys. Thank you so much.